Can anyone hear me? 1, 2. Let's see. 1, 2. Okay. You should be able to hear me. Welcome, everyone. Can you please post in the chat if I am audible? Let's see. Sound is working. Right. Are you getting echo now? Are you getting echo right now? If I can have someone from the chat give me. Okay, and there's no echo, right? Oh, echo. Okay. So good morning, good afternoon, good evening, good tomorrow to the Pacific regions. We had a technical snag, and today I'm probably going to do the show by myself. So I'll have to be monitoring the chat, although we have quite a few people in the background taking care of the chat. If there's something you need to ask, or if I miss something, I would really like it if you type in capital letters question and then a colon and then ask your question. If there are any technical difficulties, then start screaming. Use all sorts of letters and numbers and all sorts of figures and shapes to attract my attention, because the monitor is there. And the program is going to be interesting, but we're going to be missing all the usual stuff. I think they're going to be posted in the chat about any perks, any gifts, any codes, anything like that, if they're available. So I'm also going to monitor on one side of my screen the Skype, because I'm talking to people here and they're telling me what to do. Okay, the answer to Darren is yes, please monitor the chat. The same to Ellie, and we have at least 1,000 people monitoring the chat. So before I start answering the questions, we are going to see standard particles today, and we're not going to see Ellie's magnificent twirly thingy with a field force, but we're going to see other magnificent stuff from yours truly, and we're going to see thinking particles. I'm going to give you a path forward to thinking particles, so that first of all you are aware of its existence. That's number one. Potential things you can do, and how much simpler it is than a lot of people think it is. And in order to do that, I will facilitate what is called a page with notes, which is on that monitor. So now you have a full 360 view of my office. It's many monitors here, a camera there, and thousands of people watching this. So let me now switch, because I have to do the OBS switching as well. So I need to switch to my screen, and my screen is all the way down here, and you should be seeing my computer screen right now when I press. When I switched my screen, I lost my audio. So I need to just add my audio source here. Sorry, this was a last minute job. And let's make sure that this is going to work. So let's go back to this. 1, 2. Okay. You should be now able to see my screen and hear my voice. Can I have confirmation on that, please? The first interactive Maxon training channel show, fully interactive. Without you, I cannot do it. Literally, I'm not joking. So can you hear me right now? Yes, all good. I love when I hear that. Okay, so let's start the webinar right now. And the first thing I'd like to tell you is that we have a simple particle emitter that resides in here. Now, the great thing about this is that we can create some very interesting shapes by controlling where the particles are going. So this is a very simple square emitter, and it has a very simple set of parameters. The only thing I'm going to tell you, you have to be aware of the birth rates, the editor and the renderer, to make sure that everything's going to work fine when you do the final renders. Just make sure these two numbers are the same. Nothing else. That's all you need to do. And I'm going to set this to, let's say, 1,000 and 1,000 particles. And you press play and it starts spitting out particles. And that's fantastic. Let me extend my scene to 300. I'm going to rotate it because it always emits on the z-axis. And what I'm going to do here is I want to create a swirly pattern of particles. And the easiest way to do that is to create a helix. And I'm going to pick it up and go to the end radius. Let's go to the end radius, the start radius, whatever. And I'm going to make it a bit taller. And then I want to use the orientation of this spline as a mechanism to drive the particles. Now, to begin with, I'm going to make my particle emitter quite small, so 5 and 5. Audio going in and out. I think it's because my microphone is placed here, and because I'm looking at the monitors, it's changing volume. I'm going to try and keep my head a bit more steady. So now we have a stream of particles because I've made this quite small that goes upwards. And the way to use objects to create force fields inside Cinema 4D is by going to the simulate and going to the forces. The interface has changed a bit in R26, so we have better grouping, and we get a field force. The field force, the only thing you can get it wrong is if you drop a field in the fields instead of the object. The field is the mask, but the object is where we need to drop the fields. I know it sounds a bit odd, but that's what we need to do. We're going to define a field using shapes. I'm going to drag the helix in here, and we get these little dots, and these dots we can change the display. And what you will see is that these are generally just rotating where the spline is oriented. I don't even need to see this anymore, and this doesn't make any difference other than the viewport. So I'm going to turn it off here. Now, if I press play here, you will see that nothing particular happens. I'm going to set the field force to be change direction, or set up. Oh, sorry, I've messed this one up here. I'm going to move my helix closer to this, and I need to widen it a bit. And the reason I'm going to widen it is to see if any of the generated particles here are going to be affected by the field force. And set this to 20. I've got my notes here, and you can see that it's affecting how these are twirling upwards. And that's because of the shape of the helix. It's creating, it's called a vector field, and it's basically pointing these particles to go in a particular direction. Now, by changing what kind of objects we put in this list here, we can create a controllable set of particles. As you can see with the linear field, we're pushing the particles in that direction. You can change its orientation and push them in that direction. And one thing you need to remember is that the field force is infinite. It applies the forces in the whole scene. It will touch upon all these particles. Now, if we want to see a bit more about how the field force, because I am going to jump to thinking particles to show you some more complex and interesting stuff. I do remember Ellie doing one of her webinars where she shows how to use it to create a nice noisy movement on the surface of an object. So let me just check the question for a second. And there's nothing I need to reply to right now. I'm going to look at the questions all together later on. What I'd like to show you here, I'm going to go and open up a folder on my other monitor, and I'm going to show you where you can push this. I'm going to share these files with you so you can take a look on how this thing works. So let me drag a file and drop it here. This is a very simple setup that has multiple of these helices, which have been generated just using a radial cloning. And in the field force, I dragged the cloner, and the particles are driven by these splines. So you can change the direction of these splines by changing how these helices are generated. And again, you can see the setup is extremely simple. You have just a single emitter, you have a cloner that's cloning some helices, and one field force with just the cloner dragged in here. And again, I'm going to share these so you can see what you can do. I've got a few more files here. Let me see if one of them is a bit more interesting. There you go. Now, here you can see those same particles, but through a few more of these things, we can emit objects from these particles. So how do we do that? I'm going to go with a simple version of this. I'm going to put just 3 of these. And if you want to clone on particles, when it comes to standard particles, all you have to do is create a cloner, create whatever object you want to put in the cloner, and you scale it down. You select your cloner and you set it to object mode. I like to drag it last. The object is going to be the emitter. And make sure you put it in multi-instances, because that's going to improve the quality quite a bit. And now we have objects, and you can tell the emitter to do certain things. For example, to change the scaling at the end. And you see that scaling parameters don't get immediately adopted by the particles, because the cloner, when it's cloning on a particle object, we can select if the particles are going to scale or not. So now they're going to assume all the scaling. And the scaling, we just need to make sure that the initial size is fairly small and that the final size is not 47 times bigger, right? Just I did that to show you the difference, not because I forgot about it. Scale them down. And here you can change the scale as these are growing. There you go. Quite obvious here. They're growing. Now, one more thing about particles, and let me see in my list if this is going to be the last example of particles, is colorizing the particles. And I'm just going to make this a bit faster by removing some of these particles. Now, let's assume I want to add some color to these. Well, go to your cloner and add a plane effector. And make sure the plane effector is set to fields color. And in the fields, what you need to drag in here is the emitter. When you drag a particle object into a field list, the particle's life, the minute it gets born, its lifespan is full, and just before it dies, its lifespan is at its end. It maps the life of the particle to its color. And all we have to do here is go and take this gradient and colorize it using a colorizer, and just go here and add a nice, well, that's not the ideal. That's not the ideal one. And, well, it doesn't work. Well, let me open the actual file and find out why it's not working, because apparently I forgot to do something. So plane effector, colorizer, emitter, yes, for some reason it didn't work in that scene, but I'm going to share the screen. I'm just rushing through because I have a lot of things to show, and I'm a bit in a state of panic because of all this technical stuff that happened. But the idea is you take the emitter color and you colorize it. Let's see if Darren is explaining why I did a mistake. And oh, Ellie is in the house. I may bring you in a second because I haven't created an OBS link to bring you in. And sorry for all this technical blabbing, but let's go on. Again, you will have access to all these files, and you have the ability to go through and check out how everything is made. Excellent. So, any questions? Do we have any questions about standard particles? Maybe I can address something. I'm reading the questions right now. It's going to take around 10 seconds for your question to come up because I have one more little trick to show you. And 5, 4, 3, 2, 1. No questions. Hopefully no one's asleep. I'm going to show you how you can create random growths using particles. Nothing really intricate. It's extremely simple. But nonetheless, it's quite useful if you want to make permutations of things like grass or twigs and so forth. Now, get an emitter and just put it upright. So the Z is pointing upwards. And let's set this to 10 and 10. And let's change the way the particles are emitted. So we're going to add some angle. Otherwise, they're going to go perfectly straight. That's the 0 here. If I make this 15 and 15, then the particles are going to fan out in different directions. Excellent. Let's make them go a bit slower. So go to the speed. All these parameters are in the particle tab. And rewind, press play, and you can see they're going upwards. Now, what I'm going to do, I'm actually going to make this extremely small as it gets, 0 and 0. I want them to start from a single point. I'm going to zoom in, and now, with this selected, all I'm going to do is go and add a tracer. And what this is going to do is trace these paths. And I don't want it to wrap around at the end and come back. I want it to stop at frame 90. So go to Animate, Play Mode, Simple. And you can see that they're going straight up. Excellent. And now I'm going to go and add a turbulent force to make them wiggle a bit, and just go closer a bit here. Go to Simulate. Let's go to Forces. Let's add a turbulence. Let's play this and start playing with the turbulence. Just bring this up and put this down, and there you go. Rewind, press play. And now you can see they're growing in a nice pattern. Every time you get to frame 90, you can say Tracer, right click, current state to object. Now I have one set of graphs. It's going to change something in the turbulence. Let's do that. Rewind, press play. I moved the wrong one, but that doesn't matter. There you go. So now we have a second one. Go to the tracer, current state to object. Oops. Undo. And let's current state to object. There you go. We have a copy. So you can see that we have these different copies every time we change a parameter. And you can play around this for 5 minutes, create 7, 10, 20 different permutations of this, and then use these as and distribute them on your grass field, attach some flowers at the end and all that. And you can do that using a cloner very quickly. You get let's take a cube. Let's put this in object mode. Let's make the cube small. I don't know why I'm showing this, but I'm going to show it nonetheless. Drag the tracer in here and make sure you have only one. Turn off the loop and set the end to the offset to 100% and just one. So we have, this is the one I have in here. I think so. Let's remove everything else. So we have fewer things to consider. And why do I have so many? Oh, because I have too many twigs, that's why. Each little branch is going to have a tip. So this can be a flower, right? This can be, you can go and remove any splines you want. This can be a flower. It can be literally anything you wish. So very quickly using particles to create nice wiggly lines, although there are many other methods. The good thing is that they will stem from a single point, and the setup is extremely fast, and the permutations are also extremely fast. And because you can use forces, you can sculpt them in a way that they seem to be leaning in one direction or the other, or they have some sort of common parameter. Excellent. So let's close this down and let's move to the next topic, which is thinking particles, because that's where we can have more fun. Now, a lot of people are afraid of thinking particles because its core is based on Espresso. But that doesn't need to be so much of a problem, because Espresso is not as hard as you think if you follow certain rules. So the easiest, by far, way to create thinking particles is to create a matrix object. And I'm going to turn off the visibility. And instead of matrices, you tell it to generate thinking particles. And there you have it. Now you have a bunch of thinking particles. They're not doing anything. They're not going anywhere. But you have some thinking particles which you can play around with. Now, let's assume I wanted to get this grid. This can be an object, a sphere. Let me just show it for completeness. Icosahedron. Everyone knows that's my favorite sphere. Let's go and drag the object here. Now, you need to rewind in order to get it to update. And let's get here 1500 of these particles. So we have a bunch of particles which are doing absolutely nothing. Well, we do have forces, right? So I'm going to try and be smart about this and say, I want to add a turbulence. So I'm going to press play and nothing will happen. That's because a couple of versions ago, these forces didn't used to work with thinking particles, but a couple of versions ago, the functionality was added, but you need to do something very specific. We need to add, sorry, I just read a message. So we do need to add an Espresso tag. And although we can put it anywhere we want, it doesn't really make a difference in this case. I like to create a null, call it TP, or which is my name as well, Thanasis Posansis, but it's thinking particles in this case. I just like to have it separate so I can add controls using user data if I need to do that. So it's more of a habit. Right click and go and put on an Espresso tag. So the question now, and which is the fundamental basis of thinking particles, is where do we get these particles? We can't drag them in here. What is the concept behind particles? Well, the concept lies in this little menu here called the thinking particles settings. And amongst other things, like how many maximum particles can we have in our scene? If you're creating millions of particles, make sure you increase this number. What we see, if we see dots, if we see ticks, and so forth. The important part of this panel are the groups. And currently, and by default, all particles are generated in a particular group called all, which incorporates all groups of all particles if other groups exist. So if I want to affect all these particles or any other subgroup, just right click, add a subgroup, name it whatever you want, and so forth. That doesn't make a difference in our particular case. I need to reference the particles called all within my graph. And the way to do that is by using the PPass. I just type pass. There you go. It's the PPass. And the PPass just, it allows us to stream all the particles from this little output into anything we require. And that's the main way. By adding this, we can feed these particles and do things with them. We want to use a force, right? So force. And there's this new node called PForce Object. And by telling this to take all the particles in the all group, which means all particles, and put it in this force, all now the system needs to know is which force are you referring to? And you just select it, go to the attributes, and drag your turbulence in here. And this is it. This is the complete. I'm going to just drag this and put it here because I want it to access it easier. If I press play now, you will see the effect of my turbulence. I like to expand this so I can have more time to check out what's going on. So now you can start playing with this. And there you go. Instant motion. It's two nodes, the PPass and the PForce object. And suddenly you've generated any number of particles on any surface or anywhere else you would otherwise generate clones, and this is now your particle simulation. Insofar as the rest of the particle attributes, for example, a particle can have a huge amount of parameters like speed, velocity, direction, orientation, scale, life, age, and all those things. when we are generating particles in this manner, we have not set any of those parameters. So this is for you to create a bunch of sit particles, sitting particles, and then use your forces by using this method to create any motion. If you want to add another force, let's say a wind, let's go here to forces, or an attractor. Let's add an attractor. You need to add one more of these. So let me just control copy it, feed it in here, and go here and add the attractor. Get the attractor, move it somewhere, wherever I'm going to move it. You can see some of them are attracted here. Now, I do want to mention something. When you're doing multiple setups with thinking particles, a good practice, although it's not always necessary, is to split your operations into discrete little loops. Again, you won't see any problems in most of your setups, but sometimes there could be minor conflicts with the order of execution because Espresso has some funny ways of executing things from left to right, top to bottom, and so forth. So what I do in this case, for every single operation I'm going to do, for every complete loop, I make a different p-pass. This does exactly the same thing. It doesn't do anything differently, but I have an indication, a more clear indication of what these are doing, and I'm going to avoid certain types of execution errors. So now Espresso knows it's first going to execute this, then it's going to execute this. Now, I don't know if you put it on top if it's going to do anything differently, but anyway, that's a different story. Excellent. So this is the way to create thinking particles using a matrix object. Now let's go and see which way we are going to use. In which way we can use thinking particles in the MoGraph context. So I'm going to do the opposite now. I've created these particles with whatever means. It doesn't matter which means you use to create your particles. How do I use them as MoGraph cloning positions? Well, it's precisely the similar way, not precisely, sorry, it's a similar way as we did earlier. So I'm going to get a cube, and maybe I need to make my cube default much smaller. Set the cloner to be object. Now, here's the question. Where are my thinking particles here? Well, you would think it's the matrix, but it's not. The matrix just initiates that initial position. The matrix will not move. Now, if I turn this off, let's see. So you can see the particles are moving, my mistake, but I want to be able to clone these things independent of whatever the matrix is generating, because I may create spawns of the particles and so forth. And the data doesn't exist in the object manager. It exists in the thinking particle settings, the ones we found over here, the settings. And basically it's the group. You need to go here and drag the group over here. Now you're telling the MoGraph to clone on each and every one of the particles that exist within the particle group all, which is all the particles, by the way. And yeah, that's how you do it. Again, multi-instances to make sure it's nice and fast, and we have our cubes. And again, in this particular case, we can just clone the matrix. But what if your particle setup generates further particles, which is something we're going to see today with the scene I prepared for you to do fireworks. And this is the base of how thinking particles work. We take a stream of particles in whatever group they exist, we tell them to do something, and we can read data, change the data, and we can furthermore drive the particles. Now I'm going to show you the second easiest way to create particles, but with a bit more control. And this is by using a node called PMatter wave. So again, let me get my favorite sphere, which is the icosahedron sphere. I'm going to set this to 64 because I like to have some segments. And for this, you need objects to be editable. And that's the advantage of the matrix way, that you can have procedural objects fed through the matrix to create your particle surface emission, for example. But here, this method requires an editable object. There are some ways around that, but I'm not going to get into that. A null with TP, and right-click to go and add an Espresso tag. And if we go here, right there, I'm going to type matter. So PMatter waves. This is a very powerful thinking particles node. It allows you to drag directly an object in here or link it here for that matter. You can drag a polygon selection. You can emit from UVs. You can emit from lights that affect this. I have some examples on that. And it has a ton of parameters here, and everything you can control it using texture and so forth. So let's do that. Let's drag the sphere in here and let's rewind and press play. And you have particles emitting from the surface, right? Isn't that fantastic? Now there's, I think, a bit of an, yeah, when the PMatter waves is selected, for some reason, I can't go and change this. If this happens ever to you, just close the window or go to your project settings and change this. I don't know what issue that was, but just in case you don't catch it yourself. So there we go. Now we're emitting 100, let's go, 1,000 particles here. So let's see how we can create, and I'm going to show you exactly what we're going to create in the amount of time we have left. I'm going to, let me go to my Explorer and let me find my nice, there it is. Oh, it's already open. Anyway, this thing here, fireworks, boom, 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 and secondary fireworks. And you can see the scene is pretty simple. And I'm going to show you how this is done. If you look at the Espresso, you'll be like, oh my God, this is hard. It's not. And the reason it's not is that basically the graph is this, and you don't even need this. There you go. This is a graph. And I'm just using the same graph again and again and again and again. And it will create subsequent explosions. So, are you ready to see how that's done? Are you ready to see how? I'm going to start anyway. So first of all, let's create the initial emission. And let me do this. I'm going to put my panel here. I'm going to put this over here, get a bit more node space. This is how I like to work with nodes, and I have my thinking particles up here. I'm going to put this here. So, PMatter waves. So this is the basis of what we are going to do, right? It's relatively simple. Let me just I'm just doing something here so I can have my notes. Good. So because I'm going to have my initial fireworks, then those are going to explode into another set of particles. The minute the particle ends its life, it's going to become 100 particles. And then the other one is going to become, after the end of its life, another 100 particles. And that's how we create those explosions we have here. We have the original one, which is done. Oh, I removed everything, so it's not going to work like this. But if I do revert save project, it is going to work. So the first particle is what creates the orange line. When it dies, it creates a small explosion, and it spawns particles at that particular position. And then when each of the blue ones die, they spawn little green ones, right? That's how we do this. And that means I need at least 3 particle groups. One will be the initial, and it's good to have discrete particle groups if you're doing things like spawning and so forth, because then you can control each group separately rather than having them in the all. So I'm going to right-click and add 3 particle groups. Group 1 is going to be orange. Group 2 is going to be blue. And group 3 is going to be green. And that's just the particle color so we can see this. I'm going to call these initial. I'm going to call the other one first and the other one second. So this is first explosion and second explosion. Excellent. Now, when this creates a stream of particles, if we want to put these particles in this group, it's quite simple. I don't know if we can drag this directly here. Is this a P group? No, that's not a P group. Go here and type group. Now there are 2 P groups. I never remember which one is the correct one. If you drag them both, the correct one is that has the input on the left. This is to read groups and this is to a right to group. So we know which one is that. And you tell the PMatter waves to generate particles for which group? Not all, but the initial. That's how you connect it. So now when I restart the particles, you will see that it's generating orange particles. And I know that these particles are within the initial group. Excellent. Now, what else do I need to do? Well, I need to make the speed a bit slower. So let's go and look at the parameters of the attributes here. And if you want to maximize this, I think you press Control Tab. Ooh, and it maximizes the panel. So I don't want 1,000. I'm going to make, let's say, 50. I want their lifespan to be around, let's say, 2 seconds, so 60 frames. I want some sort of variation in their life. So some of them will die earlier and some of them will die later. Let's put it 30%, so we do have a significant difference. I want their speed to be slower because now their life is longer. I want them to initially move at a speed which is slower. And again, the speed, I'm going to vary it by another 30%. So let me press Command Tab again, and let's see what this does. Just pay attention over there, and you will see that we are getting different speeds, and that looks pretty interesting. Excellent. So my initial, the initial particle generation is done. That's it. I have my initial group. What I need to do now is ask thinking particles to find out when each particle dies. And when the particle dies, I want a new particle emitter to be born at that position. Did I say born? Jason born? No, P born. My name is Born, P born. So the P born node allows you, oh, it's not the P born, it's a storm. Sorry about that. I was caught up with a pun that I got that's what happens when you're in a team that have better puns than you. You focus on the pun instead of the actual knowledge. So we want to create a storm of particles. See how I switch that? So PStorm is your traditional, let's say, default particle emitter that has what you would expect as an emitter equivalent to the standard emitter, right? You can emit from a circle or a rectangle, and you have the parameters you will find in the standard emitter. Excellent. Now, if I press play here, you just see a stream of particles going that way because it's emitting from that circle. That's all it's doing. And it's emitting based on the parameters that are set in here. So 100 seems good. I want to make the size, I'm going to leave it, actually I'm going to leave it like this because I want you to see something when I do my setup. Usually I will go and change these here, but I want you to pay attention to what's happening. So let me rewind. And here's the question. How do I tell this to emit the moment a particle dies? So the first thing to do is go a step back and say, okay, I want to access this initial group and find out when they die. So I need that pass thing because I need to read data from this particle stream, but not all, but the initial one. So go back here and say, I want to read all the particles from initial. Excellent. And what do I need to read from the particles? Well, I need to read the age because I need to know when their age gets to an end, i.e. the particle dies. And the P age has a parameter that tells you when the particle is born, dies, enters a group, and does all sorts of other things. This is one of the most powerful nodes because you know what a particle is doing in terms of its interaction with other objects, not spatially, but in terms of what it's doing. It's alive, it's dead, was it just born, and so forth. So now I'm going to tell the PPass to read this particle stream. And when the age is such that they die, so upon death, I want this PStorm to fire a bunch of particles. So you connect these two ons. So every time this loops around, it will fire an emission every time a particle dies. So let me just turn off the sphere from here and see what happens here. You can see that it's flashing. And that's because it's being generated every time one of these orange one dies. But obviously, we do not want the particles to be generated at the center. We want them to be generated. So the emitter position for each and every one of the particles needs to be set at the position of the particle when it dies. So how do we get data from a particle stream? And here's where my pun works. You do a data and get a p set data. And set data, I'm not well today. Get data. I say get data and I pick set data. Yeah, there's something wrong with my glasses. So you need to feed the particle stream in here, and you can get any of these pieces of data from each and every one of the particles. And this is a stream. This little line here streams all the particles. And I want to get from these particles their position, and I'm going to feed it in the emitter position. Now watch this. It's going to be fun. It's going to start creating emitters. Look at that. Every time a particle dies, it creates an emitter. But that emitter is not aligned. So we need to align the emitter in the position of the particle traveling, right? Where is it? Where's the orange particle? Which way is it going? Now, here's one of those things that you just need to learn to do. You can go here and say, I want the emitter alignment. And you could go to the particle and say, oh, the particle has alignment. Duh, I'm going to put this in here and it's going to work. Well, the problem is that when a particle is born by the PMatter waves, although it's on the surface and it's moving in the direction of the normal, and that's a parameter you'll find somewhere down here in which direction it's going, as a normal, direction type normal. Actually, the particle itself is not oriented. It's just sitting upright as it should be. So everything is going in the z direction. There's one little step we need to do, and that's pretty much the final step, to make sure that each particle over here has an alignment which is the same as its direction of travel, the way it's going. And for that, there is something called alignment, p-alignment. So remember the p-pass? Get another p-pass and align all the initial particles to what? To the direction of travel. Boom. Now you can see immediately my new PStorm particles are generated exactly where each particle dies. Now that I have this, and that's why I left it quite big, so you can see the circles generate, so you can understand exactly what's going on. So let's go and fix this now and make it more interesting, because we need that to be a little bunch. Number one, we want to emit, so particle birth, we want to emit in a group, which is not the initial. So go to the group, I just made a copy, put it in first, and now, in theory, there should be the blue ones. There you go. So now the blue ones, the first, are the particles that are being born. And now let's go and play with the PStorm. Number one, let's make it extremely small, so 1 and 1. Number two, I want them to emit 180 degrees in each direction. So I want it to fan out. Good. Then I need to increase the number of particles. Let's put 500 here and set this to, let's say, shot of 500. I want them to be emitted the same moment. If you put rate or count, so I put count, this is 500 particles per second. If you put it in shot, this is 500 particles upon creation, right? So this is what we want because we want an explosion. The lifetime is too long. I'm going to set it to 20 frames so they can go ahead and die. And we have now the first set of firework explosions. And you can play around with a life variation, you can play around with the speed variation, and all that beautiful, beautiful size. So now you can see even more difference in the explosion. Now, here's the question. If you think about this, you just have a simple creation and you put it in a group. Then you say align them to their direction of travel, and then get the position and alignment from the particles, get the age, and when it dies, fire a bunch of particles, link these up, and put them in one group. So let's assume that I would say it's fairly simple for what it does, and it will give you an interesting start to learning thinking particles. But here's the amazing thing about this. I'm going to copy this whole thing, just drag copy down here. And I'm going to say, I want to align my first pass now. Done. Now each of the first pass are not only exploding, they're aligned as well. Then I need to take my first pass, and now we're going to have a bit of too many particles, so let me just stop the animation. Then I'm going to take the first pass, not the initial. I'm going to take their data, whatever that is. I'm going to create another explosion, and I'm going to put it in the second group. Now, be careful where you feed this, because once, if you feed this in the first group as well, then every frame, it's going to create the new group, so then the new group becomes bigger. So just make sure you've set things properly. Now we should see a secondary explosion. There you go. When the other particles die, I'm not going to make this, let's make this 200, and let's make this 150. Let's make their life, I'm going to leave it at 20, but I want their speed to be half. And now I have a third explosion. So we have a particle, then we have one explosion, then we have the other explosion. Excellent. Oh, I am creating too many particles here. So I'll make a shot with, let's say, 30. And what else do I need to do? Well, I think 10. And there you have it. This is it. This is the whole setup, and you can you can scale this up by adding more and more. You can have secondary and tertiary explosions, and yeah, I will argue now that for a setup like this, since all you need to know is the concept of this, it isn't very complicated. You just need to exit your comfort zone for a bit and try and understand the data flow. And I would love to hear feedback and requests, because if a lot of people are not requesting these tutorials, because thinking particles is a fairly old technology, there are pressing matters and subjects we prioritize. But if we get enough requests, I'll love to do some more in-depth thinking particles sessions. And if you search on Cineversity, there's quite a lot of stuff. And this particular technology hasn't changed at all in the last many years. So you're going to find this quite informative. Now let's go and add a few more perks to this. And let me read on the side just some questions. I'm going to do the line thing. So I'm going to go back to my standard. And just to finalize my visual, basically, I want to make these particles come up and create a line. And to do that, I need to bring up my thinking particle settings. Excellent. And that's the initial group. And I'm going to create a tracer object with my initial group in here. And if I press play, you'll see it creates a line. Great. But that line sort of remains there. So I need to go and say, let's go from end, and let's say 20 frames from end. I want these lines to start going upwards. There you go. So now we have that little trail, which you can put it under a sweep, or you can just render it using a line and make that little trail. And just to make this a bit more fun, if you may, and to just show the force again, if you want them to wiggle around a bit, just go and add your turbulence force. Make sure that you have another p-pass here. So I'm going to p-pass the initial. That's the one I need to p-pass. And delete this and put a force in here. Force object. Connect it up. And drag the turbulence here. And just make sure that the turbulence has some nice little wiggly stuff. There you go. Fireworks. That's amazing. And you know that you can render each particle using Redshift without using objects and all that nice stuff. How to adjust. All right, let's go to a few questions. And let's go to a few questions. I'm not going to show my face because I may mess things up with OBS and we may lose the stream. Okay, so let's start. I've got some questions here that very kindly Darren has aggregated for me. And I'm going to take a sip of coffee. Okay. One question. Those can be contained to a volume area or a geometry surface. You do that by, that's why you need to watch Ellie's fantastic twirly particle things. If anyone has a link to that, please post it. It was a fantastic presentation Ellie did for us that shows how you can keep particles on the surface by using a vector volume and stuff like that. So the other thing you can do if you want to keep them in a volume, you can create, we have deflectors and the thinking particles. If you want to see what you can do in here, it has some dynamics, it has deflectors, it can bounce off things, it has some sort of rudimentary simulation. It's one of the 7 simulation systems we have in Cinema 4D. It has gravity, it has friction, it has all sorts of things. So there are ways to contain it within an object providing. If there's enough interest, that will be a nice little quick tip. So, question, is the order of execution of execution based on the order of the node in the X manager with Expresso panel? Yes, I'm not going to go into the intricacies of Expresso, but here's sort of the execution order, I think. I'm under the impression that the magnificent Dr. Sassy has made tutorials about Expresso. I think that those are the most valuable tool to go and check out on Cineversity. But alongside them, we've had other experts like Tim Clapham and many other people doing thinking particles. There's quite a bit of stuff on Cineversity, to be honest with you. The good thing is that other than the interface of Cinema 4D, the actual parameters haven't changed. So you won't find any major issues following along with any of those tutorials. Plus the fact that if you go to the asset manager and type thinking and go to all, we have all these ready-made scenes that have a lot of use cases. I think it was one of our very best, Bjorn Mal, Shrek, that did these a long time ago, and they still, you know, they're still extremely valuable resources, and you can actually use them. So drag them in. They seem a bit more complex than they are, and the reason for that is that they've got user interfaces. The biggest part of this is the UI. So you may be afraid of this, but this is nothing more than someone creating a user data and just feeding the data throughout the nodes. This in particular is just a PStorm that just reads the parameters here. You don't even need to drive all these parameters. And the rest of the nodes, I mean, they're not too many. Here's a remark, a memory to remember where it was before, a math. So you can achieve a lot in a very small amount of time using thinking particles, but the examples are an amazing resource. And of course, feel free to ask us questions about all these things. Oh, what else did I add? Yeah, I added everything here. Oh, this is a complete scene. What am I doing? I opened a scene. I was trying to come back to this one. Okay. How to adjust timing. So the timing has to do with the speed of the particle, basically, and you don't tell it to go from one place to another in a particular amount of time where you can speed it up. But generally, one of the many parameters that a particle has, which you can see all these parameters here, is age, alignment, its color. There's a delta time factor where it was before, where it's going later on, which group it is, what its total life, its mass, position, a random seed if you want to use it per particle, which is great for randomizations, its scale, a shape if it's associated to escape, because you can, to a shape, not escape, because you can associate an object instead. Now we use MoGraph, but because back then MoGraph didn't exist, we had a P-shape node, and the shape was the link to that object. Size, spin, and velocity. And thinking particles allows you to add your own custom variables. I don't know why I said that, but nonetheless, it's extremely powerful. What was the question I read? What was the question I read? Oh, the timing. Yeah, and the timing is basically based on the speed of the particle, its lifetime, and all that. And it's mostly based on the scene. If the scene is, it calculates on a second per second basis. If your scene is 25 or if your scene is 30, Cinema 4D will take care of that. So let me now check some questions up here. Let me see if we have any new questions down here. I love particles, fantastic. Could I time this? Well, the other way to time things, you can export these particles as an alembic. And this is one of the places where I always insist that when you're doing professional work, it's good to make sure that once you're satisfied with a complex setup like this, just start baking. If the chances of making any changes is little or minimal, just bake it. That's all you have to do. And you can bake it to a Alembic cache, and then you can do your retiming and all that kind of stuff. So that will be it. Oh, there you go. We have the actual link to the tutorial. Let's see what else. Yeah, I don't understand the random. Absolutely nothing is random. And in fact, other than when you have a random parameter, everything is very, very, very specific. And just to illustrate that, I'm going to get my TP node. I'm going to add my Espresso, and I'm going to put a storm here. So again, go to export, type storm. I'm going to put a PStorm here and put my Espresso on the right. Can't see it. And if I go here and type, I want one particle in shot mode. Good. So I want one shot, and that's going to do one per frame, and put this at 0 and this at 0. Every frame, the randomization here has to do with where it's emitting from this, but let's assume that this is 0 and 0. There you go. I can see there's absolutely nothing random about that. The particles themselves go in a very specific trajectory, which and follow all these rules. If you want to add randomness, or if whatever you're doing adds its own randomness, then yes, you do get some randomness. But by default, particles, they are not simulated, they're calculated frame by frame, but they are strictly deterministic based on their previous state. You add the randomization if you wish to do so. So, how to render particles using Redshift. Yeah, let's see. I didn't try that earlier, but I'm gonna try it now. And let's go here and say Redshift. Good. Now, let's add, I think it's an Redshift, yeah. If we want to bring the thinking particles context, and that's something I forgot to say, which is very important, we can see the particles, we can use the groups in here and do all that fancy stuff. Just to let you know what I've done here, I've created an extra particle group that only creates a single frame particle life. And that is because I'm just cloning a little sphere. Boop, boop, boop. There you go. For 2 or 3 frames. That's right, because I wanted to add something there. I wasn't even thinking. But anyway, let's go and do some Redshift. Now, as far as I remember, first of all, when you want to bring the context of thinking particles, because thinking particles runs in its own little container, sandbox, so to speak, you need to bring in a TP geometry. Now, and tell it which group you want it to be. And hopefully I'm not gonna mess this up. So let's go to my thinking particles. Yeah, I forgot to do that, so I'm going to improvise. So let me put my settings there so I have them, at least for today. Let's put the second spawn in here, or the first spawn. There you go, the first spawn. Let's go back here. And the TP geometry, let's go and add a Redshift object and particles and point instances. Let's see if that's going to work, or am I totally... So this is my first thing. Let me go. Let's see if someone starts screaming, don't do this, that's wrong. Oh, obviously. Oh no, obviously I'm right. There you go. So that's all you need to do. Cinema 4D the current state of Cinema 4D, the object manager, right, let me put it that way. I'm going to rephrase. The object manager is totally unaware of the existence of thinking particles, totally unaware. The fact that the cloner knows is because we specifically dragged a particle group in here. The object manager has no idea there's a thinking particle context going on. That happens in the expressor context and the thinking particle context. The TP geometry essentially brings the context of thinking particles within the object manager. And because Redshift requires some sort of object to generate these particles, the object manager needs to be aware of it. So we bring in the TP geometry, link the group we want, or all groups for that matter, right? And then we treat it just like any other point object, point instances, and I think it inherits sizes and scales and all that pretty stuff, to be honest with you, which you can control, for example, the PStorm. Which one am I rendering? The first spawn, this one. If I go and say I have the size, all right? So this is a sort of a scale parameter. Let me put it to 1 and see. You have to regenerate the particles. Do not forget that. Let's see if that's going to make a difference. Yep, there you go. So the size of the particle gets inherited by Redshift. The Redshift team has done an amazing job managing to incorporate these parameters. But essentially, that's what you do. You can make one, and then you can take another one, name it 2, and go to your second one and grab it and put this here. So you have a different particle. You can make a third one and all that nice stuff. And then you just add your Redshift materials. And at the same time, I'm going to take the tracer. I'm going to add another render Redshift object. I'm going to go to my curve and let's see. I want to do what do I want to do? Cones, strips. There you go. So now we have the little things coming out as well. Boom. And then we have the particles. Then we're going to have the secondary particles, the tertiary particles. And yeah, the ones, I think the other ones, yeah, they're bigger because I didn't touch the scale. But there you go. That's how you render in Redshift. The only difference between anything else you've already done in Redshift is that you just need to bring the thinking particles in here using the thinking particles TP geometry. I hope this answers your question. Good. So let me see what other notes we have. Of course, we have overrun by 8 minutes. And if there are no other questions, I'm going to start shutting this down, I think we're at that time. I'm going to wait for a few comments. Anyone from the training team wants to scream at me on Skype? Oh, maybe I can check some of our other platforms we communicate on, see if people are screaming. No one's screaming, actually. Am I still? Oh, okay. I am still online. I started to, it's that thing where after 1 hour or 2 hours of talking, you realize that actually no one was listening to you. That's always fun. So show your face. Yes, I'm going to show my face. That's my favorite part. So I need to go Noseman alone. Sorry, I'm just reading out what I'm touching on OBS. I'm going to transition to Noseman's face. Can everyone see this? This beautiful Greek statue face. Excellent. So I would like, and the whole training team would like to thank you for your understanding for our technical issues that didn't allow our magnificent Ellie and the rest of the team to come online today. I hope you enjoyed this. And if you found this interesting, do not forget to share the information. Spread the word. We want as many people as possible. We're streaming all sorts of platforms. For details, just ask. I'm not sure, but I think we stream on quite a few platforms. And if you have questions, let us know. You can tag me on Twitter at NosemanGR and post any relevant questions. And what I will do is I will post on my Twitter feed or somewhere. Where can we post? Now I'm asking the team. a link to a Dropbox, or where can I put the files? We'll let you know. I'm gonna put these the files relevant to this one I just did, and all the other simpler ones with the standard particles and all that. We're gonna put it where we usually host our files, and we're gonna post a link for anyone that wants to download and investigate. I love these kind of particle setups. They're intriguing. They're mind-bending sometimes, but with a little bit of extra effort, which the whole team is willing to help you with. You can do amazing stuff with Cinema 4D vanilla version. Not to downplay the amazing power of platforms like Xparticle and so forth. That it has nothing to do with that. You need to be aware of the tools you have at hand before you start seeking other tools to do stuff. And I believe that the more you know about Espresso and thinking particles, the better you're going to become at anything, any tool, any plugin, anything you use. So that's all I have for today. I'm getting a lot of thanks and a lot of applause. Love that. I feed on applause and compliments. Can we see a bunch of compliments? At least 30 people watching. Can I see 30 compliments from top to bottom? And yeah, I'm going to put it back on the exit screen, which I have no idea what it's called. So give me a second. I lost my mouse. Let's see. There's an outro here. It's amazing. Oh, an outro. Outro? Is it that? It's not that. Oh my God. I don't know where the outro screen is. Isn't that amazing? Let me read down here. Okay, I don't have an outro scene. So I think, shall I put the intro again? That's going to be fun, just to mess with people. Yeah, I have no idea what's going on. Yes, I just touched upon this. Well, thanks for tuning in. Either way, we're going to shut down the stream and put the pre-show screen on. And I don't know if we're going to edit it out. Thank you very much for watching, and hope to see you all soon again. Thank you very much.